Hi guys, welcome back to Math with James. So last time we explained what a derivative really is. So the example is that you have a car and the car is moving at a speed, but the speed of the car is changing along the time. And we use the coordinates to represent the distance and time. So x is time and y is the distance. It could be a linear function, a straight line like y is equal to x. And it also can be a curvy line like y is equal to x squared. And could be even more complicated. I was using this function yesterday just for the sake of talking the problem with a bit of convenience. And whatever the function is, a derivative of the function is the rate of change of y with respect to the change of x. In this case, we're talking about the change of distance. And then the derivative of change of distance is the velocity. So let's take a look at some fundamentals. Let me raise the blackboard for some space. So first of all, let's go back to the linear function. What if you have a linear function which is y is equal to 3x? We know the slope is equal to 3, and then I talked about the slope of the function actually is the derivative, so the derivative is also 3. That means for this kind of movement, the speed of the car is 3. That's the speed or the velocity. And if you change it to be 4x, then the speed is 4. If you change to 5x, then the speed is 5. And then we know the derivative actually is equal to this constant number before x. If we designate a letter c to it, we can write this function as y is equal to c times x. The derivative of y is equal to c. So we use y prime to notate the derivative for the function y. All right, so now let's take a look at the other function. What if you have a function which is speed changes in this way? So y is equal to like x raised to the power of 3. So we learned the formula for calculating derivatives, and that was really helpful. So the derivative of y actually is n times x raised to the power of n minus 1. N in this case is 3. The derivative of y is equal to 3 times x raised to 3 minus 1, which is 2. All right, so that's the derivative. And we want to find the speed at time 1. We just can plug 1 in it. So the speed would be v is equal to the derivative of y at the time 1. It is equal to 3 times 1 squared, and the speed at this point is 3. And let's just see if we can get another example. If you have a function which is y is equal to 3, it means your distance stays the same all the time. In our daily language, it means the car is not moving at all. So if the car is not moving at all, the speed is 0. So whatever function like this with a constant number over here, and we can express it as y is equal to c, and c is a constant number. For such a function, its derivative is always 0. And that's all for today. I'll see you guys next time. Take care.